Hi everyone, in this example we're going to tackle a slightly different problem. Here I'm not giving you the graph that you start with, so there's actually one additional step involved in this one. And that step is your very first one, and that is to identify the basic function or parent function that's involved. In this case, we're supposed to sketch h of x equals -1/2 absolute value of x minus 2. So absolute value is our parent function. So very first thing to identify is that we're starting with the graph of y equals absolute value of x. So on here, you don't have to draw it in. You can draw it off to the side, or if you have a really good picture in your head, you can just think about it, but that's my starting function. The next thing that you have to do is identify all the transformations. So I'm seeing this negative sign out in front. I am seeing a 1/2 out in front, and I'm seeing this -2 in with the x. So one thing that can be a little bit funny when we're working with these parent functions that we're just supposed to have memorized is spotting where the quote unquote parentheses are. If this was written in function notation, I'd have a really obvious f and then parenthesis. And anything inside the parenthesis is affecting x, and anything outside of the function is affecting y. Absolute value isn't too bad because the absolute value brackets basically act as the parentheses. So anything inside the absolute value is affecting x, and anything outside of the absolute value is affecting y. Another way that you can think about this, if you like it, is with order of operations. If I imagine plugging a number, let's say I plugged 1 in for x. If you think about the order of operations that would happen after that, anything that happens before the absolute value is affecting x, and anything that happens after is affecting y. So my first step here, if I plugged in 1, would be to subtract 2. That's before absolute value, so that's affecting x. Then I would take the absolute value, then I would multiply by -1/2. So the -1/2 is all affecting y. So either way, just think carefully about what's with your x and what's with your y. The orange multiplying outside of the function by a negative, that's a reflection. That's going to flip your y values. So that is flip over y. Oh, see, I warned you in there. I was about to do it. Flip y values, which is flip over x-axis. It's a flip upside down. So I'm imagining this as my next shape. The 1/2 is also outside of the absolute value bracket, so that is also affecting y's. If you multiply y's by 1/2, that's going to be a vertical compression. So the graph will get shorter by 1/2. And then if you subtract 2 from your x's, that is in with the x's, so it will do the opposite. It will shift. Remember, adding, subtracting is shift, multiplying, dividing is compression or stretch. So that is a shift to the right by 2. So opposite of what it looks like for x's. Okay, so I can do those in the order that I listed. It doesn't matter whether you do flip or compression first, but you should do that shift last to be careful. Sometimes it won't matter if you mess up the order, but other times it absolutely will, so just train yourself to do that order of operations. Okay, so flip upside down, I already kind of penciled that in a little bit here. Let's see, and I think it actually isn't too bad. This one got a little crooked, so let's go right through. What I know is that the original absolute value graph, the two pieces have a slope of 1 and -1, so I'm just kind of following that as I flip upside down. But it would also be really good to follow some points. So on the original graph, I have 0, 0, and that is a very key point, the corner. However, when I flip upside down, I am flipping over the x-axis, so points on the x-axis don't actually move. So I still have 0, 0 on my new graph. It would be great to snag 1 or 2 other points, and what I would say is avoid having all 0s and 1s as your x and y coordinates. So I think it's fine if we want to choose a point like 1, 1, but then on the other side, let's make sure we choose a different point. Maybe we'll choose like -4, 4. Just get some variety in the numerical values you're working with. A lot of these graphs will go through 0, 0, and 1, 1, sometimes negative 1, 1 as well. So switch it up a little. 1, 1, when we flip upside down, ends up at 1, negative 1. And negative 4, 4 ends up at negative 4, negative 4. So you really are multiplying your y's by a negative 1. And then I'm still keeping these separate, but once you get comfortable, if you want to do, for example, the flip and the compression at the same time, that's a pretty easy pair to get used to doing together. When I do vertical compression, remember that I'm compressing everything in towards the x-axis. So stuff above would scooch down closer to the x-axis and stuff below would scooch up closer to the x-axis. I'm all below the x-axis, so everything is actually going to get pushed up towards it. Once again, 0, 0 doesn't move. Vertical compression by 1/2 really does mean multiply your y's by 1/2, and half of 0 is still 0. So we still have 0, 0. So I'm just going to keep erasing that since it's the same point all the way through. The point 1, negative 1 moves to 1, negative 1/2, and the point negative 4, negative 4 moves to negative 4, negative 2. So my new graph is just a flattened out looking version of my old graph. And one nice way to think about this is that if you do a vertical compression by 1/2, that divides your slope by 2 as well. That cuts your slope in half. So where I had a slope of negative 1 and 1, now I have slopes of negative 1/2 and 1/2. Okay, one more on this one. So at any point if this starts getting cluttered, you can erase some of your scratch work. So I'm going to go ahead and erase the orange one so that I can see what's going on. You could even erase original blue one if you wanted to. Up to you. Shift to the right 2. Okay, so now I need to pick up every point and move it right 2. So negative 4, negative 2 will land at negative 2, negative 2. 0, 0 will land at 2, 0. Again, if they land right on grid lines like this, you don't actually have to label them for me, but since I have a couple of graphs going on, I'm trying to be kind of careful and show you where everything ended up. And then last one, 1, negative 1/2 should land at 2, negative 1/2. So we're coming in with our slope of negative 1/2 and 1/2. Oh, and that doesn't need to be dashed. That's actually my final graph. So my final answer is that blue one. And again, erase as much or as little as you want to if you think it's not clear what your final answer is. But that's what I'm getting. This is one where you can double check yourself with Desmos, so feel free, but make sure you are sketching these by hand using those transformations because you will have to do that in class. All right, thanks for watching.